All right, hello everybody. Today we're going to keep talking about some probability, and we're going to look at what are called two-way probability tables. There's going to be a lot of vocab today, so you're definitely going to want to have some notes handy as we go. A two-way table is a frequency table that displays data from one source that belongs to two different categories. One category being represented in rows and the other in columns. So if we look at this example table here, we have the number of students, so freshmen and sophomores, who were surveyed about whether or not they are attending a school dance. Um, each entry in the table is called a joint frequency. So these four numbers in the table are called joint frequencies. You can see that 25 freshmen are attending the dance. 44 freshmen are not attending the dance. 80 sophomores are attending, and 32 sophomores are not attending. That's how we read the table. The sums of rows and columns are what we call marginal frequencies. So if we added these two up and said, oh, hey, there are 69 freshmen being interviewed here, and there are 112 sophomores being interviewed, there's a total of 105 people attending the dance, and there are a total of 76 people not attending the dance, for a grand total of, and if you add up both this row and column, you should get the same number, right? So 105 and 76 should be 181, and if we add these two values, we'd get the exact same thing. So what we can learn from this table are that there were 181 students surveyed. They were all freshmen or sophomores. 105 total planned to attend the dance. 76 planned not to attend. 112 of the students were sophomores, and 69 of the students were freshmen. And then you can break it down into individual things. And there's a lot of other things we can do with these tables, but it helps us to categorize and represent data that belongs to two different categorical groups. So joint frequencies are the individual entries in the table. Marginal frequencies are the sums of the rows and columns. They're probably called marginal frequencies because they'd be written like in the margins, like what I did here. So let's talk about this situation. In another survey, similar to the one above, 106 juniors and 114 seniors respond. Of those, 42 juniors and 77 seniors plan on attending. Organize these results in a two-way table. Then find and interpret the marginal frequencies. So I'm going to leave this up here for a minute. Go ahead and pause this. I want you to fill it in correctly and then find the marginal frequencies. Then you can come back. Okay, so let's just start. 106 juniors and 114 seniors respond. So those will not be our joint frequencies. Those aren't going to be the table entries. 42 juniors plan on attending. So this is going to be 42. 77 seniors plan on attending. We don't know how many are not attending, but what we do know is that 106 juniors responded. So that means the total of all juniors should be 106. So that's my marginal joint frequency. 114 seniors responded. So that goes down here. So I can use those two numbers, right, to figure out how many are not attending. If we surveyed 106 and 42 are attending, then the difference of 106 and 42, or 106 minus 42, would be those that are not attending. In this case, 64. We can do the same thing with these seniors. If we survey 114, but take out the 77 who are attending, you'll see that 37 are not going to attend. So we have some of the marginal frequencies. Now we just need these two. So attending, 42 and 77 would be, what, 119? 64 and 37, 90, 101 are going to attend. So the total here, 220, it looks like. And if we did everything right, that should work this direction also, and it does. So in terms of interpreting the marginal frequencies, this is 106 juniors surveyed. This is 114 seniors surveyed. This is 119 students attending, at least from juniors and seniors, and 101 not attending. Okay, so we have specific data values inside the table in our joint frequencies, and then in our marginal frequencies we get a little bit broader data, a little bit bigger look at the total picture. And that's what we have here. Okay, so the marginal frequencies again would be these numbers, the ones that we just came up with. Joint frequencies are the are the values inside the table. Okay, so make sure we just have those definitions sorted out. Okay, here's a yo-yo. You randomly survey students about whether they are in favor of planting a community garden at school or not. Of 96 boys surveyed, 61 are in favor, and of 88 girls surveyed, 17 are against. Organize these results into a two-way table, then find and interpret the marginal frequencies. Go ahead and pause this, take 2 or 3 minutes to get this table filled out, and then come on back and we'll talk about it together. Okay, so we need to organize this data two ways. We need to look at boys versus girls, and then for or against the um, the garden. So if we look back at this table, you'll see that we usually organize by in two general categories: class and attendance. So we might call this gender and I don't know, garden stance, whether they're for or against it. So 96 boys surveyed. So we're going to have boys and girls. 61 are in favor. So then we need to have in favor and against. You are either a boy or a girl, and you are either in favor or against the garden. We had 61 boys in favor of the garden, so that goes here, and 17 girls against it. There were 96 boys surveyed. That's going to be a marginal frequency, 96. There are 88 girls surveyed. So again, we can just use a little bit of subtraction here to figure out how many are in these other two columns. So if we surveyed 96 boys, 61 of them are in favor. The rest of them must be against, right? So that's going to be the 35 that we don't have accounted for. Of the 88 girls surveyed, 17 of them do not want the garden. Well, 88 minus 17 is going to be 71. There are 71 girls in favor of the garden. We have two of our marginal frequencies. We just need the other two. So 61 and 71 is going to be 132 people in favor of the garden. And then 35, 45, 52 people against the garden. So if we're going to interpret this, we should kind of probably label what these are for the garden. And that would just be students in general. And this would be students against. This would be 96 boys surveyed, and 88 girls surveyed. Okay, so not too tricky. We're going to take this one step further and look at what are called joint relative frequencies and marginal relative frequencies. The key word being relative, right? That's what's different. So let's look at the joint relative frequency first. It is the ratio of a frequency that is not in the total, either the total column or total rows, to the total number of values of or observations. Okay. A marginal relative frequency is the sum of the joint relative frequencies. So if we were to come back here to this example just for a second, let me change my color so we can see. I'll just use black, I guess. 61, because 61 is not in the total, right? Over the total number, which we forgot to fill out, total number of people surveyed. So 96 plus 88, or 132 plus 52, I'm getting 184 either way. So 61 over 184, 35 over 184, 71 over 184, and 17 over 184. Those are going to be our joint relative frequencies. And it'll show you that 61 out of 184. Let's just do that one real quick. So I'm just going to divide those. Not times. 61 divided by 184. 33.2% of the total surveyed responses were boys in favor, right? So I can do the same thing with the rest of these. If I did 35 over 184, I would find that 19% of survey responses were boys who are against the garden. So that's what the joint relative frequencies show us. And then the marginal relative frequency just shows that sum. So I would add up the 33.2 and then what did I say, 19%? So the marginal frequency here would be 52.2% would be the total percentage that were boys, which you can also figure out. So a two-way table really just helps you break down all this information so you can look at it a ton of different ways. Okay, so if we look at the exact same scenario, but back to the junior-senior dance example, I have my relative joint frequencies underlined in blue and the relative marginal frequencies underlined in red. So notice that there are 220 students total being surveyed, right? This is what we came up with way back here. 220 students, 42 juniors attending, 64 juniors not attending, 77 seniors attending, 37 not attending, and then our marginal frequencies. Those are the values we're using here. So if I divide all of the joint frequencies, all of the table entries by 220, I get the relative joint frequencies. 42 over 220, 64 over 220, 77 over 220, and 37 over 220. So you could say, for example, 29.1% of the students in the surveys are juniors and are not attending. Right? It's very specific. If you look at the relative marginal frequencies, you look at a slightly larger slice of the data. So if we looked at this 51%, remember, which is the sum of these two, the 35 and the 16, 51.8% of the students are seniors total, right? So you could also get that by taking whatever this number was. So if we jump back to that, that was 114. This 114, which is the sum of 77 and 37, and divide that by 220, guess what? You're going to get the 52%. It's just a lot of different ways of slicing up this data and looking at things to answer a lot of different questions we might have about data we got from a survey. Okay, there's a lot more in this section, this 10.3, than what's covered here. We're just going to look at part of this section. So your homework should only be asking you questions about creating tables, identifying and interpreting marginal frequencies from those tables, and then finding relative joint frequencies and relative marginal frequencies and explaining what they mean. That is the most critical part of this, not just saying, oh, the relative marginal frequencies are 54.1% and 45.9%. I want to know, what does that mean? Right? So this means that 54.1% are attending. 45.9% are not attending. And those are both juniors and seniors, right? So we need to understand the context and the labels for these data points and these values, or this stuff just doesn't have any value to us. It doesn't make sense. So using the context of the examples and understanding what these frequencies mean is the key to this. If you can't explain that, if you can't put the why behind these numbers, then doing this almost doesn't make any sense. Okay? As always, reach out if you have any questions, and have a good day.